let's get started. Who of you ever heard of aspect-oriented programming before this talk? Okay. Who used it? Oh, nice. In PHP? Oh, good luck. So, my name's Frank. I'm a web developer in the Netherlands. And I work primarily with PHP. And as I work, I'm always looking for new ways to write cleaner code. So I ran into aspect-oriented programming, which is a bit tricky in PHP. And as I explored it, I found a number of things which I would like to share with you today. If you have any questions, just raise your hand. Or if you want to, if you don't want to interrupt the flow, just post something on Twitter. I value all feedback, good and bad. So please, please be brutal. not too brutal though. So what we're going to talk about today, I'm going to cover three things. I'll talk about the origins of aspect-oriented programming, how it works, and how we can use it in PHP, and if you should. So let's start with the origins. The term aspect-oriented programming was invented at the Xerox Palo Alto Research Center, where also such great inventions as the laser printer, the graphical user interface, and Ethernet came from. It was invented there in 1995, at least the term, and they were looking for a way to separate concerns. And you know, when you develop software applications, you always want to, you know, try to separate your concerns as cleanly as possible and as much as possible. But there are some which are a bit trickier, and mostly the things which are like throughout your code. So stuff like access checking, logging. That's usually everywhere, and you can't. It's very hard to really abstract that away from your business logic without jumping through hoops. So they were looking to really separate those concerns. And let's take a look at some PHP code to see what I'm talking about here. So here, can everybody see that all right? Okay. So here we have a get secret method, and it starts by checking access and throw an exception if the user is not allowed to do something, then gets a secret, and then logs that the secret has been accessed before returning it. It's pretty straightforward, right? Well, this method is actually, although it's called getSecret, it's actually concerned with multiple things. It is responsible for checking access to the secret. It is responsible for fetching it, and it's also responsible for logging that it has been accessed. So it has, although it should have one concern, it actually has three. And this poses some problems. So why is this a problem? In 1995, these researchers, they published a paper where they explained the problem that they were trying to solve. And what they were aiming for was to extend programming languages with possibilities to really separate these concerns. And in this paper, they described a number of points which they ran into as they tried to do this. So I'm just going to read you these points. The first one. Programming intertwined code is hard and complex, since all concerns have to be dealt with at the same time and at the same level. So basically this means that if you're working on code like that what I showed before, you not only have to worry about getting the secret, you have other things to worry about as well. And although the example I just showed is relatively simple, there are cases where this can be much harder. Like for instance, if you Who here uses MVC? Oh yeah. So if you have a controller, you're very familiar with the fact that controllers tend to get fat, right? If you don't pay attention, and there's lots of stuff going on a controller that like deals with everything. And if you want to refactor such things, it's hard because you have to like focus on 10 things at a time because it does all sorts of stuff. So that's one of the problems that they ran into. That it's just hard to have all this stuff together. The extended programming language provides no adequate abstraction of concerns at the implementation level. So they couldn't find really a way to get rid of that. It just wasn't possible in the language. And the language they were working with was Java, though it's true for most languages. You can't really separate that without doing crazy stuff. So that's one point. The second one, intertwined code is hard to understand because of the above lack of abstraction. So yeah, you read code more often than you write it, right? So if you have lots of stuff going on with different things, and you look at it, it's hard to understand if there's lots of things going on, instead of if it would just be one thing. Commingled code is hard to maintain and modify because the concerns are strongly coupled. So if you want to change something about getting the secret, you also have to change, you also have to deal with all the other stuff that's coupled with it. You can't just change the secret and expect things to work. Maybe you also want to do something with logging or access checking because, it's there and you can't really change one thing without changing the other. And if you want to change like logging throughout your application, you're going to have to go through everything, through all of your, anything that deals with logging. You have to go through all of that and change it there. So it's intertwined with everything, which makes it very hard to maintain and modify. And the last point, the intertwined code gives rise to inheritance anomalies due to strong coupling of different concerns. It becomes impossible to redefine a method implementation or the commingled special concern in a subclass without redefining both. So what this means is that if you have this getSecret method, which does multiple things, which you have here, and you want to change how it gets the secret. So you extend your class and you re-implement the getSecret method, but you can't just change how it gets the secret. You also have to re-implement logging again, and you're also going to have to re-implement access checking again, which is a pain to do because now you have duplicate code and you have to maintain both of that. So ideally, you just want to turn this into something like this, and then have like some other class worry about where things should be logged and when, and have some other class worry about when access should be checked and what should happen with that. So you have all that logic centralized. And that's kind of what they tried to achieve with aspect-oriented programming, to solve this problem. Now, as they researched it, there were a number of available techniques at the time. Some of these are very old, but none of them really did what they wanted. They really didn't really solve the problem, and they weren't really ideal. So they were looking for a technique to be able to do that. And as they worked on these things, they did a number of different projects at Park with very clear abbreviations, very easy to understand. And as they released these, they got much closer to the solution. And through this, at some point, they came up with the term aspect-oriented programming. And finally, in April 1998, they created AspectJ. And AspectJ, basically, it's an extension upon Java, which implements aspect-oriented programming. And the concept pioneered in AspectJ is basically what inspired any other AOP implementation in any other language. If you're working with AOP in any other language, mostly the concepts you're working with are ones that were pioneered in AspectJ. And even today, aspect J is the de facto standard for you doing AOP in Java. So as I'm going to explain the terms in PHP, it's all basically it's based on an aspect J. So how does AOP work? And more specifically, how did aspect J work? Well, in Java, before you run code, you compile it to bytecode. And aspect J primarily works at compile time. So basically, what it does is you have your business logic, getting the secret. Then you have an authorization aspect, for instance, which checks access before getting a secret. Yeah, it's all separated, and you have logging, it's logs after getting a secret. And during compile time, it would combine all of that into what we had originally. And this is actually what's run. So it's a bit of a hack. It gets all these different parts, and it puts it together, and it produces different code, which is then run on runtime. So let's go through some of the terminology that's being used in AOP. A cross-cutting concern. Now, cross-cutting concerns is actually the functionality you want to remove from your business logic. So it is that functionality that cuts through multiple layers of abstraction, hence its name. So if you have your application in multiple layers, the cross-cutting concerns usually affect multiple of them or all of them. So you have logging, you have everywhere. Caching, you have on multiple layers. Access checking. So that's the cross-cutting concern. Then you have aspects. And aspects, basically it means it represents a way of looking at your application. So an aspect could be looking at your application with logging in your mind. So a logging aspect. So how does my application log, and where and when? Or access checking. So an aspect is a self-contained module that describes when to do something in your application, and it's when to perform one of these cross-cutting concerns. Then you have advice, and advice is basically a piece of code which is executed the moment an aspect should be applied. So it's actually this logging. So when we look at this, our logging aspect, the advice is actually this piece of code here. That's the advice. I don't know why it's called advice, because aspects are enforced, they really impose themselves upon your business logic. So it's a bit of a misnomer. It's a bit like my mother, who also gives very good advice. So this method, it has a single piece of advice, which is applied to your business logic. The next term is join points. Now, join points is where you connect your aspects and your advice to your business logic. So it's where you inject your advice. So here, one join point could be before a method call. So that's where you could inject your advice. And there are several different join points, but the ones I'm going to show you are the most common. After a method call, which is useful for logging or handing off things to worker processes, or around the method call. So you could basically wrap functionality around your business logic. So this is useful for caching or output buffering, catching exceptions, logging, stuff like that. Now, another point is another term is point cuts. Now, point cuts, they're basically a specification of join points. So they describe which join points a piece of advice should be applied to. So it could be, before the set user method, or after the set secret method, if the argument was 21, if the first argument was 21. Usually they're expressed in their own domain-specific language, so something like this. So before the execution of any method, of any public method of the secret service with any argument. So you could go, pretty nuts with this if you wanted to. And the last term is weaving. And this is actually the act of taking your business logic, taking your aspects, looking at which aspects apply to which piece of business logic, and then combining that into a new functionality which is actually executed. So you're weaving the cross-cutting concerns into your business logic. So let's take a look at how you can use it in PHP. Well, can you use it in PHP? It's a bit tricky because PHP doesn't have compile time. So you can't really before you execute your code, you can't really adapt functionality to implement your aspects. So you have to, there has to be some other way you have to do that. And usually, even though many things are not possible in PHP, but for some reason they always find a way, right? To just, they work around it, or they hack something together, and they still get it done anyway. That's PHP. So there are many implementations of aspect-oriented programming in PHP throughout the years, but these four are currently actively maintained, as far as I know. All of them are libraries, except AOP PHP. That's a PHP extension. And all the libraries you can install with Composer, which is very, very, very useful. Though not all of them can be used everywhere. Flow AOP only is part of the Flow framework. So I think it's a component, so you could bring it out, but it's mostly designed to work with the Flow framework and JMS AOP bundle. Yeah, it works only with Symfony. So I'm going to focus on these two, because they're the most portable and you can really reuse them across your projects. So the first one, AOP PHP, works like this. You define a function or method, which is your advice. In this case, we're logging. And then you call the AOP add after function, and you specify your point cut. So where you want this method to run. And then you specify the name of the function. I think it also accepts callbacks, but I'm not sure. It would be nice. But there are a number of issues with this. First of all, I don't like having to install the PHP extension. That's and chances are, if you have to install this extension and you're using like shared hosting or something, then chances are big that you won't be able to pull it off to get it to run. Also, the extension is in beta, so I don't know if they would actually install it. It is, however, much faster than any other solution. That's the advantage. So it might be worth to look at if you have like your own infrastructure, or you manage your own infrastructure. Then having this extension might really expands the possibilities. Now here I call the AOP add after function, but there are some others as well. You have AOP add before, AOP add around, so you can implement different ways of injecting your aspects. Also, another problem is that it only has like global functions, so you're gonna have to put that somewhere, which is could be a pain. Now the second solution is Go AOP, which is a PHP library, and it's userland, which works a bit differently. Actually, it jumps quite through a lot of hoops to get it done, but it's an interesting approach. Basically, when you instantiate a class, Go's autoloader comes into play, and it intercepts the instantiation of your class, and then it checks if any aspects should be applied to that class. So it checks if there are any point cuts which describe this specific class, and if so, it'll hand it off to the weaver, which will get your original class, it'll copy it, and then it'll get your aspects and the advices, and it'll actually put the advices in that class, so it will generate a new class which extends your original class with the new advices applied, and then make sure it has the same name as your original class. And then actually requires that, so it includes it, loads the class, and then that's what you instantiate when you run it. So it's an interesting approach. It involves a great deal of code generation, so it has some performance issues, but you can cache things, so that's a bit of a plus. But it does make things a bit harder to debug, because the code that you run is not the same code that you write or read. So that is an issue. So let's take a look at some code at how Go works. Here we have our logging aspect, and we specify the point cut in an annotation. So we say after the execution of the public method getSecret of the secret service with any arguments, run this function. And this method gets passed a method invocation object, and this object contains, well, everything you need to know about the original function call. So in this case, we're getting the arguments, and the first argument that would be the ID of the secret, and then we log that. So it's pretty easy. You can do some more cooler stuff as well. Around, here we use the around annotation, which basically wraps the original method call. So we start by getting the arguments again, and here we're implementing caching. So we're seeing if our cache has this secret, and if so, we return it. And this would mean that it would bypass the original execution of the function. So the original method doesn't ever get called in this case. If not, we continue, and we call invocation proceed. And this will actually execute the original method, and it will return well, whatever that method is supposed to return. Then we cache it and we return it. So this, we can use for well, caching. We could also do exception handling. I've used this to when building an API, and I'll just have all the code throw exceptions, and then in the end you catch this exception and generate a proper response. You could do that. So there are pretty cool stuff that you can do with this. You can really separate your cross-cutting concerns from the rest of the code. Then again, should you use it? You can do some cool stuff, and you can really write cleaner code. Then again, there are some issues with it. Performance is one. If you're gonna generate a great deal of code, you're gonna have to think about that. You can't just generate all that on the fly on production servers and don't not expect performance issues. So you're gonna somehow have to pre-generate that, I guess, which can be a problem, especially in larger deployments. Another thing is clarity. It makes things difficult to understand if you don't standardize how you use aspect-oriented programming. So because when a new member joins your team and they're trying to fix a bug and they're looking at code and they see, oh well, this is just getting a secret. I don't really understand what's happening here. Then you have a problem. So you should really document how you use AOP and what you use it for, and when you use it. So because the code you look at, it doesn't really you can't really see which aspects are applied to that. So you really have to standardize that and make sure everybody's aware about how to handle things. And the last thing is, you don't want to go nuts. Because you can go really crazy with this. You can you can use it for more than just cross-cutting concerns, and that's what people sometimes tend to do. And so they build their business logic of aspects upon aspects, and you get all these really small, nice objects, but it's so insanely complex that you have no idea what's going on anymore. And it's just bad architecture. If you it's crazy. So don't do that. Be pragmatic about it. You have to use it what it's good for and really stick to cross-cutting concerns and simple things. But basically you want your business logic to still function without any aspects applied to it. If it doesn't function without your aspects, then you're doing it wrong. Now it's okay if then it doesn't log things, or it's okay if some other concern is not applied. So if access is not checked, that's you don't want that, but it's logically for your code that's what you want. You don't want the get secret method should still be able to get the secret without any aspects being applied to it. And as soon as you don't have that anymore, if you need your aspects for your core business logic to function, then you're doing it wrong. You shouldn't do that. So you need to think about these things before you decide to AOP all the things. It can go pretty crazy. Thank you very much.